This is just a review of solving a few different types of equations. So that first one, probably one of the more tricky ones here. We want to get the a by itself, so we'll circle that. We're going to draw our line of equality. But then there's one other thing that we want to do to set this problem up. Make sure you do it, otherwise you won't get a 2 on this one. Box the square root, exactly. So we box the square root here because we need to get that square root by itself before I can get rid of the square root. That's one of the things I'm going to have to get rid of to get the a by itself, but I can't get rid of it until I have it by itself. I also can't get rid of the stuff that's inside of it until I get rid of the square root. All right, so we need to get that by itself, and how are we going to do that? Subtract 7. All right, so we're going to get rid of the 7 by subtracting 7. We'll do that on both sides. And on the left side, the 7's cancel, leaving what? The square root of negative 2a plus 3. And on the right side, 10 minus 7 is 3. Okay, now the square root's by itself, right? Right?
No.
So since the square root is by itself, we now need to get rid of the square root. So how are we going to get rid of the square root? We're going to square it. Remember, a square is opposite of a square root. And remember also, a square, or any exponent, needs to go up and to the right. I still see a few people putting squares like over here, or even down here sometimes. Make sure your squares go up and to the right. All right, and if I square the left side, then I need to square the right side. All right, so on the left side, when those squares cancel, what does that leave us? Okay. And on the right side, 3 squared is? 9. All right, now we just solve like we normally do, right? Right?
Yes.
Okay, so what do we do next? Subtract 3. Do that on both sides. And when we subtract 3 on the left side, what do we get? On the left side? Negative 2a. And on the right side, what do we get? Okay, then what? We're going to divide by negative 2. And when the negative 2's cancel, we get a equals negative 3. Moving on to the next one. We have a little problem on this one. So I want to get the c by itself, so I'm going to circle it, but there's another c, so I need to circle that one also. So our problem is, I want to get c by itself, but c's in 2 different places. So should I get rid of the 2 or should I get rid of the 3?
No.
Good answer, Alejandro. No, neither. What should we do?
Add them together.
Add them together. We can combine these because they're like terms, right? So the first thing we're going to do here is we're going to combine like terms, and 2c plus 3c is
6c.
5c, right? So we add the coefficients, 2 plus 3 is 5, and we keep the variable part the same, so we get 5c. All right, now, since I did that on the left side, what do I have to do on the right side? Just bring down the 15, right? So I didn't actually change anything on the left side except the way it looks. Remember, if we add something or subtract something or we do some operation on one side, we have to do it on the other. But when we combine like terms, we're not really changing the value, so we're just going to bring down what's on the other side. Now we just have a one-step equation here, right? So to get the c by itself now, what do we need to do? Divide by 5 on both sides. And when the 5's cancel, we get c over here, and 15 divided by 5 is? 3. One more equation here. This one, I want to get the h by itself. And I need to draw my line of equality. So there's 2 things I need to get rid of, the 2 and the negative 5. Which one of those 2 things should I get rid of first? The 2, okay. So remember, order of operations backwards. Since that minus 5 is inside the parentheses, that's the first thing we would do with the order of operations, so it's the last thing I get rid of. So I do need to get rid of the 2 first. So I'm going to get rid of it by dividing by 2. And when we divide by 2 on the left side, what do we get? H minus 5. And on the right side, negative 6 divided by 2 is? Negative 3. Okay, then what?
Plus 5.
add 5 to both sides. And when we add 5 on the left side, those 5's cancel, leaving h, and negative 3 plus 5 is 2. Did anybody do this one a different way? What Alejandro did here, first of all, you should still circle the variable and draw the line. But this is another way we could do the problem. So what Alejandro did is he multiplied 2 times h and 2 times negative 5. What do we call that when we multiply a number times everything inside of the parentheses? Trajan? What do we call that? Distribute, right? So this is the distributive property. So what Alejandro did here is he distributed the 2. So he distributed, and what that means is, since this 2 is being multiplied by the whole parentheses, we can just multiply it by each thing in the parentheses, each term in the parentheses. So when we do that, we get 2h minus 10, because 2 times h is 2h, and 2 times negative 5 is negative 10. And then on the right side, when we distribute, we're not really changing the value, so we just bring down the negative 6 over here. We didn't multiply this side by 2, we just distributed the 2 that was already there. So we just bring down the negative 6, and then we can solve this like we normally would. Now, if we were going to solve this, what would we get rid of first?
10.
The negative 10 by doing what?
Adding 10.
By adding 10. So we're going to add 10 on both sides. And when we add 10, we get 2h on the left side, and negative 6 plus 10 is 4, right? And then to get the h by itself, we're going to divide by 2 on both sides, and the 2's cancel, leaving h equals 2. Is that the same answer we got the other way? Is that the same answer we got? Yeah, it's the same answer we got. So either way we do it, we get the same answer. Now, you'll notice that the other way we did it, this way here, it only took us 2 steps. We divided by 2 and simplified, then we added 5 and simplified, and we got our answer. In this one, we distributed, then we added 10 to both sides, then we divided by 2, so it took us 3 steps. It took us an extra step. It still gave us the same answer, though. All right, this is actually something that we're going to be doing today. We're going to have to do the distributive property sometimes in order to get a variable by itself. All right, for this equation right here, it doesn't matter which way you do it. You get the same answer. They're both right. They're both valid solutions, so either way is okay.